Alright guys, welcome to our channel Code with Sunny, and today we will be discussing the fourth problem of the series of problems jump game. Its index is 1345 and it is the hard problem, right? So I would strictly recommend you guys, if you haven't solved similar problems starting from jump game first to the jump game 7. Okay, so let me just open it up, all the problems. You can see jump came first, it is second, and it is third, finally fourth, fifth, sixth, and here it goes seventh. Okay, so you can see, yeah, I've already solved all these problems. You can see the submissions goes for the today's date, 15th of January, and again for the jump game 2, 15th of January, and again jump game 3, 15th of January. Yeah, I've similarly solved all of the problems. So I would also recommend you guys to check your skills, check it out once again, solve it out, and let's see how much you can solve that efficiently within the given time limit. Okay, so today we'll be discussing this fourth problem of the series of problems jump game. Okay, so this was quite much interesting. Yeah, you can see it is the hard one, and I usually like hard problems. So given an array of integers ARR, and you are initially positioned at the first index of the array. Okay, and in one of the steps we can jump from index I, that is the current position, to the following positions. Okay, so that is you can move to the next position. That is, if you are index I, you can go to the index I plus 1, provided I plus 1 is within the bounds of the array. And similarly, if you are at index I, you can go just beyond the current index, that is the I minus 1, provided this I minus 1 is within the bounds of the array. Also, from index I, you can go to the index j, where the array values at index I and index j are exactly equal, and index I must not coincide with the index j. So you can go to that index also. And finally, you need to return the minimum number of steps to reach the last index of the array, that is the n minus 1th position, if you are considering a zero based indexing. Okay, and it is obvious that you are not going to jump outside the array at any time. So I'd be discussing all these examples, and with the help of all these, like these are the jumps that we are going to do in detail. For now, let's look over the constraints. Let's see which type of solution is this problem is going to demand. You can see array length is around 5 into 10 raised to the power 4. So we are going to work upon O of n solution, or in the worst case O of n log n solution. Okay, and the array values is going to lie within this range. Also, I need to mention, like you can see, my submissions is around 1 2 3 4 5 6 7. I have submitted 7 solutions. I was actually trying to improve the runtime of this problem. So you can see I was first having 658 ms, because I was implementing a logarithmic time solution like n log n. Okay, and finally I have been successful in having O of n solution. Okay, so I'll be focusing on O of n solution. For now, let's understand this problem with the help of examples. Okay, so let me pick a example from this problem statement. So it is like yeah, 100 minus 23 minus 23 and so on. So 100 minus 23 minus 23, and what are 404 100 404 100, and you can see 3 times 23, and finally we have 3 followed by 404. Okay, so we are at the index 0, that is we are at the index having the value as 100. Okay, and there are 3 possible ways to move or to perform the jump operation. That is, if you are at index I, go to I plus 1, that is the next index, provided I plus 1 exists. And similarly, you can go to I minus 1. Okay, and there is a third operation you can also do. Also, you need to understand that here the condition is array of I and array of I plus 1. There is not any condition of for these two values. It can be equal to this array of I plus 1, or it cannot be equal to this array of I plus 1. We are not interested in that. What is being performed over here is that if I and I plus 1 are adjacent, you can always move from I to I plus 1 as well as I plus 1 to I plus 1 in one jump operation. Okay, and there is a third condition also. From index I, you can jump to the index j, only and only when array of I is exactly matching with array of j. Note that j can be adjacent to the index I, but j can be with the gap greater than 1, strictly greater than 1, but this condition must hold true. So let's analyze over this example how this is going to be done. So you can see initially the minimum number of jumps required to reach the index 0 is 0. Okay, so from here you can jump to this position because it is the adjacent, so minimum number of jumps required to reach to this position would be 1. Okay, and what about satisfying this condition? You can see the value is 100 over here, and here it is also 100, so you can jump from over there to over there in one jump operation. Okay, so if you have been asked what is the minimum number of operation to reach up to this position, you will say 1, that is starting from the index 0. Okay, now what we are going to do is at this state we have all the minimum values over this index, and this index. Now we will treat these indexes as our source points, and we will try to find out the other unknown values for rest of the indexes. That is, I will use this value, and that is this position, as and the minimum value is 1, and I will check it out whether this position is reached or not, that is visited or not. You can see this is not yet visited, and you will say minimum number of jumps required to reach to this position would be 1 plus 1 exactly equal to 2, that is jump from this one to this one. Okay, now I am treating this as the source point, so let's check it out what are else other ways you can jump using this criteria. Okay, so you will see minus 23 is only over here, and there are no more minus 23 values. Also you can check over this position, that is going to I minus 1. Okay, so you can see I can jump from this one to this one, so minimum number of jumps required is 1 plus 1 exactly equal to 2, but this one is already visited and the minimum value is 0, so you're not going to update this and say yeah it requires 2 values, so it will be wrong. So indirectly I'm saying that we are performing a breadth first search starting with the index equal to 0. Okay, and you can see the next value is like 100 and the minimum value is 1. Okay, so I will check it out whether I can reach to the adjacent positions or not. You can see yeah I can reach to this 23 in one more jump, so minimum number of jumps required would be 2, and again I can reach to this 404, minimum number of jumps required would be 2. Okay, now I would be start working for the 2, like minimum number of jumps for the 2, so I would be working for the 404 number, you can see over here, and I also working for 23 number, that is for this index, and for this index also, for this 23 also, because its minimum number of jumps would be 2, that is I'm working level wise. You can see initially I've been working for the value equal to 100, that is for this value, and the next I'd be working for the values equal to you can see, sorry, initially I'm working for the level equal to 0, and next I'll be working for this 23 value with level 1 and 100 value with level 1. Next I'll be working for level equal to 2. You can see this is 2, this is 2, and this is 2. Okay, so we'll be working for this. Okay, so what we are going to do is, you can see 23 can reach to this one, can reach to this one, and all those 23 values, but all are being visited already, so we are not interested now. Now comes the value 404. Okay, so you can reach to its adjacent position, which is 100. You can see it is already visited. You can check out for the left one, 23, which is already visited, and there is one more position, you can see 404 over here. It is not yet visited and it is satisfying this condition, so you are going to say yeah 2 plus 1 will be the minimum number of jumps, so it is 3. Okay, you can see this is actually the end of the array position, so our answer is 3. Okay, minimum number of jumps, let's check it out. Yeah, you can see it is coming out as 3. Okay, so let's also try to find out the rest of the values. Okay, you can see now I'd be working for this 23. Okay, so you can see its adjacent position is visited, but you can see this position is not yet visited. You can see, so value would be 2 plus 1 would be 3. Now you can see you can also visit this position under this condition, so you would be saying yeah I can visit this one, so it would be 2 plus 1 exactly equal to 3. Okay, so here you can find all those values lying over there. using the help of breadth first search. That is, you are going to work for the level equal to 0 first, then you are going to work for the level equal to 1, and so on until you find out the last index which is being visited now. Okay, so for each current step you would check it out whether I can go to the left position using this one, or I can go to the right position. Note that the left and right should be still not yet visited. If it is already visited, no need to check it out that again. Okay, and again this position I to j, and these values must be equal. You can also jump from this index I to this index j directly, starting from, like, you can see if you are at this 404, you can jump to this 404 directly because the values are being same. Okay, so until you found the last index, you can do the same operations. So let's look over the code how we are going to implement that efficiently. So I will try to just show out this one. Okay, so what I've done is, like, I've taken this array dot size in the variable n, which is the size of this array, and this unordered map. Yeah, so this is actually hash map where I've been tracking the, like, some first element will be like unique element and their occurrence in the actual array. Okay, you can see mpf array of I dot pushback I. I'm storing the indexes. Okay, so every time what I will do is, starting from this level equal to 0, you can see the element comma jumps. I will push into the cube to perform a breadth first search, and I will mark those uh, uh, intermediate values which are being visited using this visited variable, sorry, visited vector. Yeah. Okay, so each time I will pick out this element and minimum number of jumps. Note that the breadth first search works in a level order traversal, so you need not to maintain a different different condition or for loop, you are going to say, like working for all those levels right now, then jumping to the next level. You can do that also, but yeah, this, if you are doing performing a breadth first search traversal, it will manage that already. It will manage already, like all those performing this level wise traversal. So if anytime v reaches the n minus 1, your answer will jumps and we are done. Okay, so no need to just check out for finding out the rest of the values. You can find that, but there's no need. Okay, so check out the next value. If it is within the bounds of this array and not visited, just visit them, and a minimum number of jumps would be jumps plus 1, and push into the queue to for further processing. So if v minus 1 also doesn't exist, and like v minus 1 exists and it is still not yet visited, visit them and update the minimum number of jumps. And also you need to just check it out that if the value array of v is not present in the map, then we are not going to do this operation. Otherwise, if this value array of v is present in this map, we will do the third operation. You can see the third criteria. What is that? You can see if for this one array of j, if values are same, I will jump directly to that indexes. So this map, hash map, will help us to perform that efficiently. So I will iterate to all those indexes, and if those indexes are still not yet visited, I will visit them and I'll push them into that index and jumps plus 1. Right, and once that unique value has all the elements, all those positions being visited, there is no need to visit them again. So I will erase that entry from the map. So this will actually reduce the time complexity by a large amount. Okay, so finally if we reaches the end position, thus we are done, and finally return the answer. This will give you all test cases passed. So if you guys have any doubts, do let me know in the comment section of the video, and don't forget to like my video, share my video, and subscribe to our channel for the latest videos. Thank you for watching this video.